Hello everyone, welcome to my channel. In this video I have one integral that I would like to look at. It's the integral from 1 up to 6 of the square root of x squared minus 6x plus 9 dx. So we are to evaluate this. Now where do we start from? We're looking at the expression under the square root sign. Clearly you can see that this is a quadratic expression. So the question we have to ask is, can we factorize this? If we can't, we have to try and complete the square of that because we have the square root sign here. That would be the approach. But in this case, looking at minus 6x plus 9, it can be factorized. So let me take you through the factorization process. Right, step by step, we have the integral from 1 up to 6 of the square root of x squared minus 6x plus 9 dx. So like I said, we have to factorize that expression there. And what we do is the following. I'm going to do it right as part of the solution. So x squared minus 6x plus 9. The steps are as follows. You take the first term there, x squared, multiply by the last term, the constant term. The answer is going to be positive 9x squared. We call this the product. And then basically the sum is the term in the center, which is minus 6x. So we're looking for two factors of 9x squared, whose product obviously is 9x squared and whose sum is minus 6x. We're counting from 1 for someone who doesn't know how to approach it. Counting from 1, we take 1 into 9, the answer is 9. Because the product is positive, either both are positive or both are negative. So both are negative or both are positive. And we add these up because we're looking for the sum. Adding these two, the answer is minus 10. Adding those two, the answer is positive 10. So counting from 1, you go to 2 naturally. But can 2 divide into 9 to give you a whole number result? The answer is no. So we move to 3. Can 3 divide into 9? The answer is yes. So we take 3 into 9. The answer is 3. Like I said, because of the positive sign there in the product, either both are negative, these two terms or factors, or both of them are positive. So negative, both of them, or positive, both of them. Now, adding these up, the answer is minus 6. Minus 3 plus minus 3 is minus 6. And that's what we're looking for there, remember. So therefore, each of these terms carries an x because we are looking for minus 6x, this one which is there. So these two terms must come and replace the term in the center. So we're going to say now x squared minus 3x plus 9. And we pair these up as follows. Process called grouping terms. So the common factor there is x. Take it out. X into x squared, the answer is x. X into minus 3x, the answer is minus 3. And the common factor there, respecting that minus sign, obviously you'll agree with me that is 3. Right? Minus 3 into minus 3x, the answer is x, positive. Minus 3 into positive 9, the answer is minus 3. Now we have a common factor there and there. You can see the common factor. This is the common factor found both here on the first term and the second term. We take the common factor out, which is x minus 3. And then x minus 3 into x, open brackets, x minus 3, the answer will be x because these two terms cancel. So the answer is x. And then we are saying this expression into that expression. Obviously, you can see the answer is 3 because this cancels that. You are left with 3. But what is this? This is exactly equal to x minus 3 all squared. Right. So that integral, therefore, changes to the integral from 1 up to 6 of the square root of x minus 3 all squared dx. Now, here we have to be extra careful because we're dealing with a definite integral. And when you are dealing with a definite integral, and there is a square root sign that you have to integrate, an expression involving the square root sign, rational expression. In this case, we call it a radical expression. When you have that expression there under the square root sign, we're focusing on the positive square root, not negative square root. So we're looking at the positive square root, and therefore we have to make sure that x minus 3, which is the square root of x minus 3 squared, is positive. And for us to do that, we introduce the idea of absolute value. So this is the integral from 1 up to 6 of the absolute value of x minus 3, and we're saying dx. Now, that makes sure that we are looking at the positive square root of this expression. Now, because this can never be negative, so we have to ensure that it's never negative by using the absolute value sign. Now, I must take you through the concept of absolute value just to remind you, because I did speak about absolute value a couple of videos back. By definition, the absolute value of x, we say, is equal to x if x is positive, or minus x if x is negative. So this means that the absolute value of x minus 3 should be equal to x minus 3 if x minus 3 is positive. What does this mean? This means x is greater than 3, or minus of this expression, x minus 3 if x minus 3 is actually negative. And what does this mean? This means x is less than 3. And what does this mean? If we simplify that part, it's minus x plus 3. So now we have two functions, that one and that one, that we need to focus on. Our integral has to break down into two integrals, as you will see shortly. Now we have two functions. Like I said, we have to graph now y equals x minus 3, and the condition is this is for x is greater than 3. We also have to graph the function y equals minus x plus 3. This is for x is less than 3. Now, reminding you, these are two linear functions, very easy to graph. Here is the Cartesian plane, and we're focusing on, remember, on y-axis, x is 0, and on x-axis, y equals 0. So the way that we graph this is by simply saying, let's start with this one. Remember, the condition is x greater than 3, not greater than 0 here. Must be careful. X is greater than 3. You can see it there. X is greater than 3. I'll come and fix that. So we're basically saying here, when x is 0, y equals minus 3. You're down there. Let me just be a bit childish here. You'll see why I'm saying I want to be a bit childish. Two numbers, minus 3. When x is 0, y is minus 3. When y is 0, you can add 3 on both sides. X is gonna be equal to 3. So basically we're saying you have a straight line passing through these points. Let me just graph that line. There is your line passing through those points, right? But remember, the focus is that x must be greater than 3. It means you are interested in from here going that way. Therefore, this is why I was saying, let me be a little childish. This part of the graph must go, because we're focusing only on the right hand side of 3. So the graph must start from there going that side. We're not being very strict there, otherwise this is supposed to be, the 3 is not inclusive with this condition here, x greater than 3. But yeah, this is just fine. And then let's look at this one. When x is 0, y equals 3. Why are we saying x is 0? We want to look for the y-intercept. So when x equals 0, y equals 3. So we are somewhere up here, somewhere there. What about, so that is going to be 3. When y is 0, so for x, you can add x on both sides. X is going to be 3. You are there. So again, I want to be childish here a little bit. Drawing the graph, there is your graph. But remember now, our focus is from 3 going to the left. X must be less than 3. So it means the part of the graph which is on the right hand side must go. There you have it. So now we have a graph, a V-shaped graph, basically having a cusp, what we call a cusp at 3. At 3, the function is not differentiable. It is also not integrable. Therefore, it means that we have to split our integral into 2. This integral has to be divided into 2, because we are looking at from 1 up to 6, which includes the 3 there. So it means we must move from 1. Let me say 1 is somewhere there. Our integral, we're evaluating from 1 all the way up to, remember, from 0 up to 3, and from 3 up to 6, the distance must be the same, because we're dealing with 3 being half of 6. So basically, this is what I'm saying. So we're interested in that area, added to that area, that will be the value of our integral. This will be 6 here, from 0 up to 3 and from 3 up to 6, the distance must be the same. But remember, we're integrating from 1 up to 6, so it has to be 1 to 3 and then 3 to 6. But this graph here, don't forget that this is y is equal to minus x plus 3. There it is. And this one here is y equals x minus 3. Therefore, our integral, this one here, changes as follows. This integral changes as follows, taking us to, this was page 2, if I'm not mistaken. This was page 2. I want to move to page 3. So we're basically saying, reminding you where we come from. This is the integral. If I can just hold it here, this is the integral. You can see it, right? Yeah, this is the integral. So we're saying that integral, therefore, changes to the integral from 1 up to 3 of what? Of this function here, minus x plus 3. Minus x plus 3 dx. And then we're going to say plus the integral from 3 to 6 of that function. From 3 to 6 of that function there. So integral from 3 to 6 of which function? X minus 3, and we have dx. So this integral basically splits into two, that part and that part. Now let's evaluate the two integrals. Very straightforward to work on, as you would see. Now the first part, let me move back a little bit. The first part, the integral of this part here, you can agree with me that the answer is minus x squared over 2 plus 3x. Limits of integration were from 1 up to 3, and we're saying plus. What about this part here? Well, the integral of x is x squared over 2. The integral of minus 3 is minus 3x. Limits of integration 3 up to 6, right? So let's work this one out then. So putting 3 there and there, what you have now is minus 3 squared over 2 plus 3 times 3. And we're saying this, we are supposed to subtract this from this lower limit, put 1 there and there. It's going to be minus half plus 3, if you like, putting 1 there and there, right? And then I have plus coming 6, bringing 6 there. It's going to be 6 squared over 2 minus 3 times 6, and then we have to say minus. Now we take 3, put it there and there, so it's going to be 3 squared all over 2 minus 3 times 3, like that. Now simplifying the first part, this is minus 9 over 2 plus 9 plus half minus 3. Remember opening these brackets, and then we have, this is 18 minus 18, because that 36 over 2 is 18. This cancels, 0 basically, and that will be minus 9 over 2, and then we're going to say plus 9, because that is minus 9. When you open the brackets there, you have positive 9. Now these are gone, so what do we have now? 9 plus 9, so I'm going to have 9 plus 9. That takes care of this 9 and that 9. Like I said, these are gone, giving you 0 there. And then I have minus 3, and then I have minus 9. So first let's take minus 3, and then we have minus 9 over 2, minus 9 over 2. That takes care of that part and that part, and the minus 3 has been taken care of already. Now we have to say plus half. Now this is 18 minus 3. This part here, if you agree with me, is minus 18 over 2, which is minus 9. And then I'm going to say plus half. So this is 18 minus 12 plus half. You'll agree with me that basically the answer is 6 and a half. 6 and 1/2. This is our solution. Square units, if you are very interested in indicating that this is basically area, or you can just leave it the way it is. Now again, I want to just emphasize the idea or the fact that when you have a definite integral and you're dealing with a radical function, square root of something, you must make sure that you take the positive square root, and therefore introduce the idea of absolute value here to work out the to evaluate this integral. Without the absolute value, you'd come up with a wrong solution. These are questions that are not very straightforward. It looks very simple, but not very straightforward because of the idea of the absolute value. Looking at this integral here, one would not easily see that it requires you to introduce absolute values. But yeah, this is how it's done. I've done a similar one in a couple of videos back. This is the second one so far on this, and I'm trusting that you now understand that you have to be extra careful when you're dealing with this. All right, I'm going to stop here in this video. If you're new to the channel, support us by subscribing. I'll see you in the next one.